Hey CW Apes, Mr. Kennedy here with a special video for you today on global warming and climate change. When you think about global warming and climate change, well, there are some truths and fallacies that we kind of need to kind of work through and hash out and just sort of just deal with it, face value. So let's dig in. Global warming. You know, when we think of global warming, some people think global warming means the whole planet is going to get super hot. That's just not how it's going to work. Some places on the planet, yes, will probably get warmer, but other places might actually cool off. The idea in global warming isn't that the entire planet is super toasty, it's just that the average temperatures on the planet go up. This is what climate change is about. What is climate change? Well, remember, climate is like a long period, a specific set of like weather conditions that you can expect based on where you are, right? That's what your climate is all about. And so is the climate changing? Yeah, I think it is. And here's how we know. If we just take a look at some data that's out there on like temperature, mean temperature changes over land and ocean, you can see just from a graph like this that from 1880 to beyond 2000, it's getting warmer. The question is why? Like, why is it getting warmer? Why are temperatures going up? And it's hotly contested and argued and debated about again and again and again. I don't think we can really argue whether or not the Earth is warming. I think the really big argument is, are humans making it worse? This is a contentious issue, but the contentious issue is not that the Earth is warming. It is, are humans making it worse? So what are humans doing? Like, what is the Earth normally supposed to do that humans are messing up? Well, let's look at this. Some natural causes of climate change. Well, when you think about natural climate change in our geologic history, there are several points in history that are pointed to as ice ages followed by tropical periods, and lots of speculation as to what could have caused those ice ages and subsequently those tropical periods. One of the most telling things that we use to try to explain that kind of oscillation in Earth's history is carbon dioxide. Carbon dioxide levels naturally oscillate between summer and winter months. In the winter, carbon dioxide levels tend to build not because everybody's like, I don't know, driving cars and stuff like that, but because there are fewer plants doing photosynthesis in specific hemispheres as it gets really, really cold, right? Like deciduous plants all drop their leaves. So that reduction in photosynthesis causes CO2 levels to increase. In the summer months, that script is flipped because now you got all these plants that are alive and well and photosynthesizing like crazy. So CO2 levels go down. So if you think about this connection between like CO2 and these ice ages and these tropical periods, remember, CO2 is a greenhouse gas. It traps heat energy, right? So something must have happened to maybe raise CO2 levels that might put us then in an ice age. And I don't know what that something is, but sometimes people speculate that it could have been volcanic activity, could have been a meteor impact. Who knows? I wasn't here. But as a case in point, in 1991, there was a volcanic eruption that emitted large amounts of particulate matter, ash, and dust. And this volcanic eruption, like, you know, the ash cloud actually like went 40 kilometers up into the air and spread out rapidly. Now, this ash cloud, you know, it's almost like created a nuclear winter. The ash cloud itself reflected the sun's energy and ultimately dropped the temperature in the northern hemisphere of, basically 0.5 to 0.6 degrees Celsius. So could a volcano or lots of volcanoes erupting at the same time literally block out the sun, cool the earth off, and lead us into an ice age? It's a possibility. It's one idea, right? The albedo effect of that cloud works like this, okay? So the light color of a cloud or even snow or ice is very reflective, and solar energy hitting that will just bounce off. So if you've got this, big cloud of ash and soot, that's blanketing huge expanses of area, you could expect the majority of the solar radiation that used to penetrate to the ground and keep things warm or even just drive photosynthesis is not going to make it. And if it doesn't make it there, plants will die. That's another thing that takes CO2 out of the atmosphere. So, well, we'll come back to that in a minute. But before we deal with that, like temperatures are going to drop. So maybe this cloud blocks so much solar radiation, it gets so cold that we hit an ice age. Now, eventually, plants, like I said, plants are going to die from being like in this cold and not being able to photosynthesize. But also, at the same token, think of it this way: that ash cloud will eventually go away, the solar radiation will reach the earth, and some plants will survive. Some plants will survive this nuclear winter, if you will. And yeah, and the CO2 that's in the atmosphere that the plants used to take out from photosynthesis, well, that's going to build up and that's going to trap heat and that's going to make it warm and maybe drag us right out of this ice age and allow the plants that did survive to basically take over and get to a tropical period in our Earth's history, right? So that's just one idea. So an albedo effect, well, it's all about reflecting solar energy. If you're lightly colored, you reflect. If you're darkly colored, you absorb. No matter how you look at like heat energy through albedo effect, the heat energy does also need to be distributed across the planet, and that's what our oceans are for. So this is the great ocean conveyor belt that basically moves heat energy through our seas, where you have warm water, right? That basically creates rising currents of air, warm air that rises up and distributes heat from there. That's next thing we got to look at is the greenhouse effect. So the greenhouse effect is where all these gases in our atmosphere work together to trap the sun's energy. So this greenhouse effect we learned about in a separate video can be impacted through human activities. Under normal circumstances, these gases are kept pretty much in balance by nature, and yeah, the planet is kept warm enough to support life. But through human activities, we can add excessive amounts of specific gases like methane and nitrogen oxides, or even just carbon dioxide, and we can throw the greenhouse effect out of balance. Have we affected climate? I don't know. Let's look. The atmospheric levels of greenhouse gases from 1978 are graphed here for you on this slide. Here's carbon dioxide, nitrogen oxide, methane, and our CFCs. So as you look at each of these, you can see carbon dioxide, nitrogen oxides are on a steady incline. Methane went up for quite a while and has kind of leveled off. It's got a little peak here again back in 2010. Your CFCs have pretty much leveled off, mainly because of the global ban in their use. But there are still some CFCs around, because remember, their life expectancy in the atmosphere can be upwards of 100 years or more. Okay? Who are the major contributors to these greenhouse gases? Well, if you look closely at this map of the Earth, you're going to find it looks kind of funny. Like there's some spots that are kind of big and bulgy. Well, the reason that there's some spots that are big and bulgy is because these are global warming culprits judged by size. So if you look close, the countries that have caused the disproportionately largest amounts of global warming are like, bulging. So who's bulging in this map? Yep, the US and the, European Union, or basically all of the UK, Germany, and the like. Right? So we're doing the most damage, and you can see how much that temperature increase we've created. CO2 levels and temperature over the past 20th century on this graph show a trend where they are simply continuing to increase. A little bit of up down here and there, but overall the trends show that temperatures are increasing, and so too are CO2 levels. So what effects have been happening with climate, and what is this going to do to life? Well, let's look at this. In the past 15 years, we've experienced 12 of the hottest years on record. Like, look at some of these temperatures that we're seeing across the United States. Temperatures as high as like 125 degrees in places like Death Valley. It's like record breaking, unbelievable temperatures. And even areas that were used to being hot are getting like way hotter. Okay. What does this data show? Again, This is from 1850 through 2007. It's just showing the trends of increasing temperature on a global scale. Ice caps are melting. We're losing our polar ice caps at alarming rates, to the point where so much ice has melted now that scientists believe we have actually passed like the point of no return, which basically means even if we stopped putting CO2 into the atmosphere today, it's already done enough damage, so much damage that like we can't stop that ice cap from melting. It's just going to go. Ice caps melting can cause sea level to rise. And in some countries, a sea level increase of just a few feet could be disastrous. Um, we're also seeing increases in like dramatic weather events. This is just the US annual tornado count. And as you can see, that as a result of climate change, like we get different influxes of warm and cold air, or increased influxes of warm and cold air, which can lead to increased incidences of things like tornadoes and hurricanes. So it's even changing our hardiness zones across the map. We're actually moving things around to kind of adjust for the fact that the growing seasons, well, like aren't necessarily like winter's not as cold as it once was, and summer is much hotter. So plants that maybe couldn't live in one part of the country at one point now can, and vice versa. So how do you determine if humans are enhancing the greenhouse effect? Well, um, really, it's a lot of polling. We're starting to see a growing consensus and increasing certainty. People are starting to just buy into the idea that humans are having an impact. 97 out of 100 climate experts agree that humans are causing global warming through their activities. Okay, so what do we expect in the future? Well, we can expect temperatures to change. Average global temperatures are expected to increase by anywhere from 2 to almost 12 degrees Fahrenheit by the year 2100, depending on the level of future greenhouse gas emissions and what we do. That can have a direct impact on biodiversity, warming climates, and shifting seasons. There are plants that are accustomed to cold that aren't going to get it, and plants that are accustomed to hot that might get so much heat that they can't take it anymore. This means in terms of plants, well, plants can't necessarily get up and move when conditions aren't suitable, but through the spread of seeds and things like that, they can migrate to other areas of the country, right? Most plants will not be able to adjust to the changing climate conditions because they're occurring too fast for a species to migrate, which means we could lose a lot of biodiversity as a result. Potential impacts on human health. Well, climate change can change temperatures, it could change sea levels, it could change precipitation rates, volume and all of that. So that can lead to storms and flooding, which can cause morbidity and mortality and displacement. It can change heat, like making some areas so hot and inhospitable that it again increases morbidity and mortality. It increases vector biology, which basically means like if areas are getting hot, you could have greater incidences of mosquito-borne diseases like malaria. You could have respiratory diseases from air pollutants. You could have people suffer from malnutrition because our agricultural production will be hindered as temperatures and climatic things change around the farm belts of our world. You can even have civil conflict as people start to fight for limited resources. So just to kind of bring this to a close and think, big picture, here are some effects of global warming on agriculture, right? So we're going to potentially lose biodiversity in our fragile forests. We could get increased frequency of storms, floods, and droughts. We can get longer growing seasons in colder areas, but shorter growing seasons in hotter areas. We can get dramatic changes in the distributions and quantities of fish, more unpredictable farming conditions in tropical areas, even an increased incidence of disease and vector-borne diseases that can affect both people and farm animals. The ocean, in and of itself, well, could suffer greatly from increased levels of CO2 in our atmosphere. Remember what I said about photosynthesis? Well, early on, photosynthesis was portrayed as the great sink to pull CO2 out of the atmosphere. The ocean is too, but remember in this case, like photosynthesis does something good with that CO2. The ocean just basically soaks it up, and as carbon dioxide comes in contact with water, it forms carbonic acid, acidifying the ocean, which again, in a natural cycle, might break down coral, which can neutralize that acid and bring things back into balance. Because a lot of coral has skeletons made of calcium carbonate, which is a natural, like, base to counteract the acid of carbonic acid. But if you've got so much acid in the ocean that you're dissolving coral faster than the coral can replenish itself, then the coral just dies, right? And the ocean as a whole loses that vital ecosystem, that vital food chain, that vital food web. And, if the pH of the ocean drops to something even close to a pH of 5, we'll lose all of the life in the ocean. So what do we do about it? At the end of the day, how do we deal with, global warming? It's all about prevention, folks. We just got to identify the source and control the release of greenhouse gases and carbon dioxide that can lead to this global warming scenario that I've portrayed for you here. Look for alternatives to fossil fuels. Look for cleaner technologies. Look for more efficient technology. Like, look for economic incentives and ways to get people to buy in. And through international regulations and cooperation, like, we can change the world, folks. It's up to you. I hope you've learned a little bit about global warming and climate change from this video. I'm Mr. Kennedy, and I will see you next time.